guys. Okay. So we'll get started with the next chapter, that is wave optics, right? So the chapter that we discussed before this, that is chapter 9, was about ray optics, right? So what did we deal in ray optics? So ray optics was about, sorry?
We saw light as a ray there.
So light as a ray in the sense, you're trying to say when light is interacting, with whom? With objects whose size is compared to that of wavelength.
Wavelength.
Comparable to the wavelength of light, we deal optics under a branch called as ray optics. Similarly, what is wave optics? So wave optics is a branch of physics where we deal with the behavior of light when it is interacting with an obstacle whose size is very small compared to light, whose size is very much small than the wavelength of the light, then that branch of physics is what we call it as wave optics, or more technically, it is also called as physical optics. Okay. Now, basically, before this concept of wave optics came into picture, right? We know that light is an electromagnetic wave, right? So before it was understood or found that light had a wave nature associated with it, it was a corpuscular theory which was more in domination. So corpuscular means particle. So it is a particle theory of light that was in greater value at that point. So Newton, what he proposed is, he proposed that light travels in the form of particles. But later, what happened is the wave theory of light came in picture in the year 1678. A scientist named Huygens suggested that light travels in the form of longitudinal waves, just as sound travels through. Okay, that is what he proposed. Later, it was known that light had and all those things after the electromagnetic theory description. But he told that light had wave nature associated with it. So he proposed that light waves propagate through orbiting hypothetical medium called luminiferous ether. Okay. So these Newton was the being at that point of time. People didn't believe when they told, when Christian Huygens told that it had wave nature associated with it. So what happened? Later, there was a scientist named Young who did the Young's double slit experiment to prove that light had wave nature associated with it. So these are all the theories that happened. Later, what happened after a few years in the 20th century, it was understood that the concept of photoelectric effect believed or proved that light has particle nature. So in today, we know that light has both wave nature as well as particle nature associated with it. Both these things put together will give the dual nature to light. Okay. So in this chapter, we are going to deal with light as a wave because it is going to interact with those objects whose size is very small compared to that of the wave of light that is being used. So first we will see an important term called as wavefronts. Then we will see a term called as phase. I'm sorry, I have a lot of technical issue. People are sick in my house, so I'm not able to move around. So circular pattern of alternate crescents begin to spread out in the form of impact. Sorry, from the point of impact. So clearly all the particles lying on the crest are in the position of their maximum upward displacement, and similarly all the particles lying are in the position of their maximum downward displacement and therefore in the same phase. So what will happen is if you take the locus of all points which are in the same phase, then that is what is defined as wavefront. So to put it in simple terms, what we are doing is the source that is generating these ripples is a stone. A stone is of point size. So due to this point sized object, you are able to see that the water is traveling in the form of these circular ripples, right? So the locus of all these points put together is what we call it as a wavefront. What exactly is the locus? Okay, I'll tell you. I'll tell you. Suppose I take circle, okay? So circle has a center O, and let's say there are points, okay? There are points which are equidistant from the center. Then when you join all these points, what is the shape that you will get? That is a circle. So you can define circle like this. Circle, I'm talking in terms of mathematics, okay? Because you wanted me to explain what locus is. So circle is basically the locus of all points which are equidistant from a fixed point. So the locus of all points which are equidistant from a fixed point is what we call it as locus. In a similar way, what is wavefront? Please write it down. So wavefront is defined as the continuous locus of all such particles of the medium which are vibrating the same phase at any instant. Okay, now let me explain how the different types of wavefronts are going to occur. So the geometrical shape of that particular wavefront, see for example, the stone created circular wavefronts. Similarly, if you talk about the geometrical shape of wavefront depending on the source of disturbance, then we can say there is something called a spherical wavefront, there is something called a cylindrical wavefront, and there is something called as plane wavefront that is existing. So what is a spherical wavefront? So spherical wavefront, as the name suggests, In case of waves traveling in all directions from, so if you take a point source, then what will happen is, see, listen. If you take a point source, from the point source, you will have waves that are going to come out like this, right? When you join all these points which are in the same phase, so you know what is the phase? If you take a wave like this, then for a phase, I can say that this is the displacement of the particle. So when you join all these particles put together, then the shape that you're getting is what is called as wavefront, and this wavefront is what is called as spherical wavefront. Okay, so due to a point source, the wavefront that is getting generated is spherical in nature. Okay. Similarly, if you take a linear source, so due to a linear source, the wavefront that is formed is cylindrical in nature. Similarly, if you take plane wavefronts, so due to the rays which are due to the source at infinity, what is going to happen is the wavefronts that are getting formed are plane wavefronts. Okay, what's this? I've explained what is cylindrical and what is plane. The next concept is ray of light. Okay, so it is seen that whatever is the shape of the wavefront, the disturbance always travels along straight lines emerging from the source. That is, the energy of the wavelength travels in a direction perpendicular to the wavefront. That is what they're trying to say. So what will happen here is, if you talk about a ray of light in simple terms is just an arrow mark that is drawn perpendicular to the wavefront in the direction of propagation of wave. Okay. So generally, when you talk about a ray of light represents the path along which the light travels. So if you're going to measure the separation between a pair of wavefronts along any ray, you're going to measure the separation between a pair of wavefronts along any ray, it is found to be constant. Okay, that is first point. So from this, you can illustrate two general principles. One is rays are always perpendicular to wavefronts. Second is the time taken for light to travel from one wavefront to another is the same along any ray. So these are the two important points that you need to make a note of with respect to a ray. Okay, please make a note of these 2 points. Okay. So what they're trying to say is, if a wavefront is given to you and you're asked to draw the rays, you need to draw the rays just perpendicular to those surfaces. That's it. Now coming to an important theory of the Huygens principle of secondary wavelets. Please write it down. So if you take Huygens principle, that is considered as the basis of wave theory of light. Okay. So it mainly talks about how the wavefront propagates through a medium. So according to Huygens, it is important to note that each point on a wavefront is a source of secondary wave which add up to give wavefront at any later time. So try to understand this, guys. Okay. Now we are going to discuss something about a point called as wavelets, not wavefronts. So Huygens principle of secondary wavelets means the principle is based on the following assumptions. So each point of a wavefront acts as a fresh source of new disturbance called secondary waves or wavelets. Okay. So each point on the wavefront acts as a fresh source of new disturbance called as secondary waves or wavelets. Second, the secondary wavelets that are getting spread out in all directions with the speed of light, the secondary wavelets start spreading in all directions with the speed of the light in the given medium. And the third important thing is, if you take the new wavefront at any later time, it is given by the forward envelope of these secondary wavelets at the time. Let me explain each point. All these 3 points are very, very, very important. But before that, tell me if there is any doubt till whatever we discussed. Is there any concept that you want me to explain again? Guys, any concept that you want me to explain again?
No, sir.
Okay. So this point is very important according to me. So this Huygens principle is based on the following assumptions. That is, each point on a wavefront acts as a fresh source of new disturbance, which we call it as secondary waves or wavelets. So here we are not discussing about wavefronts. We are discussing about wavelets. Meaning, if I take a point source, so due to that point source, what will happen is due to the point source, there is a there is a wavefront that is created. Okay. So each point on this wavefront will act as a source for the new disturbance. Means this point will start creating a secondary wavefront, and that secondary wavefront is not technically called as a wavefront. It is called as the secondary wave or wavelet. Okay. And this is called as secondary waves or wavelets. Now what will happen is the secondary wavelets will start spreading in all directions with the speed of the light in the given medium. So if it is traveling, let's say in air medium, then it will start spreading in all directions with the same speed of light in that particular medium. Now what will happen is you have the new wavefront. For this new wavelet, you need to draw a tangential surface which will give you the new wavefront. Which will give you the new wavefront. So this is the secondary wavefront. Okay. So based on this, there is something called as Huygens construction. This Huygens construction is something similar to the construction that you follow in your mathematics. Okay. So it is basically a geometrical method of locating the new position and shape of a wavefront at any instant from its known position at its shape at any other instance. So what will happen here is consider a spherical or plane wavefront moving towards right. Let AB be the position at any instant of time. Let AB be the position at any instant of time. The region of its left has perceived the wave while the region on the right is undisturbed. So what is going to happen is, now from here, each point on AB becomes a source of the secondary disturbance which travels with the same speed c. So to find the new wavefront after time t, what you need to do is you calculate the radius as ct, keep this small a as the center, and take the compass and put a circle around it. So we'll draw spheres of radius ct from each point on AB. Then what will happen is the forward envelope of the tangential surface means once you draw these dotted circles, you take the tangential surface with respect to whom? You take the tangential surface with respect to the new wavelet, then that is going to give you the new wave front after time t. Okay. Similarly, if you see for this, the lines A dash, BB dash, CC dash, all these things are going to be perpendicular to both AB and CD. Also, these lines, the energy flows from AB to CD. So these lines represent the rays, and rays are always normal to the wavefronts. So these are the rays that they are trying to talk about, and we know the fact that the rays are always perpendicular to the wavefront. Okay, so if this construction is understood by you, only I can explain you the next theory. So ensure you just go through it, and if there is any doubt, get it clarified. No doubts? Done, guys?
Yes, sir.
So write down the next concept, that is, we are going to explain the concept of reflection of light on the basis of wave theory. Okay. So we are going to prove the laws of reflection on the basis of Huygens wave theory. See, what we will do is, you will consider two parallel rays. So you are going to consider two parallel rays which are falling on a reflecting surface xy. So both the wavefront and the reflecting surface being perpendicular to each other. So we know that the wavefront and the reflecting surface being perpendicular to the plane of the paper. Now what will happen is, as soon as this first wave is there, right? As soon as the first incident ray touches the reflecting surface, then what will happen is it will start generating the secondary wavelets. Okay. So what we need to do for that is first draw a wavefront like this. So when you draw a wavefront in this way, then what we can do is, from each point on BC. So if you take each point on BC, what will happen is there will be these kind of wavelets that are getting generated. Now observe. So the first ray has already hit the surface, and the second ray is traveling an extra distance of c into t in time t. Okay. So due to this CT, what is going to happen is, from this point, take the CT as the radius and cut an arc. That is going to be the radius of the spherical wavefront that it has generated in time t. So when it has generated something like this, then from the second point of incidence, so from the second point of incidence, this would have started generating rays like this. Now these both, let's say they are meeting at this point, and you can find that point by drawing a tangent from the second point of incidence till here. Because what did the tangent tell us? So the third point, what is, say, the forward envelope at any later time is given by the tangent drawn to the surface at that particular point. Right? So you want a tangent to be drawn like this. Then this tangent is going to give you the reflected wavefront. But we know the fact that wavefront and rays are always perpendicular to each other. So from the first point of incidence, just join this line so that you will get this point. And this blue color line represents the reflected ray. Okay, this represents the reflected ray. This is a complicated concept, guys. Try to understand. If there is any doubt, get it clarified. Okay, this is called as reflected ray. And from the second point of instance, if you draw a ray perpendicular to the wavefront, that is also a reflected ray. Okay, so all these diagrams we drew based on the Huygens principle of wave theory, and based on Huygens construction, we drew this. Any doubt till here? So I'm hoping there is no doubt, right? Okay. Now, by drawing all these things, what you have done is you have created a base. So if you observe, this angle is I and this angle is R. Okay. So if this is I, then this is going to be 90 minus I. Then this is going to be 90 minus R. If this, sorry, this, correct? If this is 90 minus R, then this whole angle will be R. Then this whole angle.
Sir, I think it's correct only. 90 minus.
Sorry?
It's 90
Which
minus R only.
Correct only, no? 90 minus R.
Yes.
No, what is your doubt?
No, sir, I just confirmed that it's 90 minus
Yeah,
1.
see, I'll explain it again. Listen. Did you understand that this is R?
Yes, sir.
So this is a ray, this is wavefront. Ray and wavefront are perpendicular to each other. So this should be 90 minus R. Right? So this is a normal and this is a reflecting surface. So out of 90, 90 minus R is gone. How much is this? It is R. Correct? In a similar way, if this is I, that is the angle between the incident ray and the normal is I, incident ray and incident wavefront are perpendicular. So this will be 90 minus I. Normal and the reflecting surface are perpendicular to each other. So this will be I. Okay. Now what we will do is we will consider the triangle ABC and DBC, or I can say DCB. If you observe, angle A is equal to angle D is equal to 90 degrees. Angle A is 90, angle D is 90. Now, BC is common side. BC is common side. Similarly, I can say BD is equal to AC. Why is BD equal to AC? Because with B as a center, you drew a wavefront to point D. From A, you have drawn to point C. So BD is equal to AC means BC is common side. AC is equal to BD. So I can conclude that these two triangles are congruent. So when they are congruent, what can I say? I can say that the angles are going to be equal. So angle ABC is equal to angle BCB. So angle B is equal to angle C. That proves the laws of reflection. So what you have done is you have proven the laws of reflection on the basis of wave theory of light. Got it, guys? Got it or not? So I know this is a tough concept. See, the first part of wave optics is always tough. Okay. The next part onwards, you'll be able to understand it better because it involves a little bit of mathematics and it's all about equations only. But this part is the toughest. For you to understand this part, what I've done is I've already recorded a video where I've used a compass and protractor and all those things and explained this concept in that video. Okay, I've explained the concept of reflection on the basis of wave theory and refraction on the basis of wave theory also, which I will put it in the app today. So what you guys do is you go through these concepts before tomorrow's class so that tomorrow my job also becomes easy and you will be able to understand it better. So with this concept only I have to stop because I cannot go beyond this as the topics are getting tougher. Right? Are you able to understand what I'm trying to say?
Yes.
Right. So what I'll be doing is I'll be sharing a video of the concept of reflection on the basis of wave theory and refraction on the basis of wave theory. You guys go through that concept before tomorrow's class. One more thing. So tomorrow will mostly be a morning class, but what has happened, unfortunately, everybody has tested positive in my home. Okay. So I have to see what is the feasibility and then decide the class. That is the reason I couldn't take the class yesterday also. Now also it is slightly difficult for me, but I will check and update you. Mostly you'll have morning class. If I'm able to take it, maybe I'll take it for 45 minutes or something like that. I can't take for 1 hour. So I'll inform you guys. Be mentally prepared for it. Okay. So once I share the schedule, ensure you're going through these videos before you come for tomorrow's class. Okay. So that's it from my side, guys. You work.
Thank you.